Okay, hello and welcome to lesson 3 on inequalities. So the previous two lessons, the first lesson we looked at showing inequalities on number lines. The second lesson we looked at this one, solving linear inequalities and then representing it on a number line. And in today's lesson we're going to look at just writing down whole number values that satisfy an inequality. Okay, so you should have ticked off these two so far, assuming you've been fine with the first two lessons. We're going to look at this middle one here today. So solving linear inequalities and finding integers. Now the first thing to say is that the idea of an integer, okay, if you don't already know this, you must write down the definition of an integer. Okay, an integer is a whole number. Okay, so make sure you've highlighted that phrase, make sure you know that an integer is a whole number, okay? Because in the questions, they will not ask you to represent or to find whole numbers. They will ask you to find integers. So it's just important that you know that they are the same thing. So for this one, what I've got here is I've got an inequality. Now, if I think about how I'm saying that n is greater than -2 or n is less than or equal to 3, okay? Now, in the question, it says that n is an integer, so n is a whole number. So very simply, I need to list the possible values of n. So what values of n could I have? So if I think about this methodically, I think n is basically in between -2 and 3. That's what I've got there. Okay, greater than -2, but less than or equal to 3. And if you wanted to, you could display this on a number line quickly and just look at the numbers. But I think if we try and visualize what we're looking for here, we're looking at the numbers in between -2 and 3. So looking at -1, 0, 1, and 2. Now the only real decision you have to make is at the ends of your inequality, okay? Do I include -2? Do I include 3? Okay, and we should be able to see from the symbols that n is greater than -2, okay, can't be equal to it, but n could be equal to 3. So I can include 3 in my answer. Okay, so that would be your answer. Those are the whole numbers which work for this inequality. Okay, all these numbers here are less than or equal to 3 and greater than -2. Okay, so copy that example down. Very similar, okay, a lot of these questions tend to use the same wording, the same kind of style of question. We've got our inequality here, n is greater than or equal to -4 and n is less than 1. N is an integer, okay, so we're looking at whole numbers. If it didn't say that, this question wouldn't be possible because you'd have an infinite amount of numbers in between -4 and 1. Okay, so it will always say something about integers which triggers your memory of whole numbers. Write down all the possible values of n. So again, I'll write down the numbers in between -4 and 1 first of all. Just a reminder that 0 is an integer, it does count as a whole number. And again, we just need to check the ends here. So can't be equal to 1, so I'm not going to include that. It can be equal to -4, so I'm going to include that in my list. So that would be your answer there. Okay, so copy that one down if you feel like you need another example. Now, rather than just that kind of standard example, what these questions have evolved into over time is that you don't just have the letter n in the middle of your inequality. Sometimes you will have a bit more work to do before you can get the answer. And this is all about combining kind of yesterday's lesson with today's. Because what we've got to do first of all is we've got to do a little bit of solving to get the inequality to then say what the integers are. So if you look at this one, it's important to note, and it is important to check this, that in the middle here is 2x. Okay, and you need to be careful with that because a lot of people will look at that and just straight away start listing values and say, right, okay, the numbers in between -2 and 6 are these numbers, I can have that, right, I'm done. Okay, but that's not the answer, okay, because I've got 2x here. So the first thing I want you to do is to deal with that 2x in the same way that you would with an equation. So if I've got 2x equals something, I would divide by 2. So if I divide by 2 here, and you need to divide the whole inequality by 2, you'll get -1, you'll get x, and you'll get 3. So now that I've turned it into a normal inequality, I can just list the integers as I would do usually. So in between -1 and 3 is 0, 1 and 2. Check the ends of my inequality, no to 3, yes to -1, and that's your answer. Okay, so copy down that example and make a note of the fact, maybe highlight the fact that you've got 2x in the middle there. You've got to deal with that first before you then try and list the integers. Okay? Now, very similar, but we've got 3x this time. And this does involve a little bit more thinking. First of all, when you look at that question in comparison to the previous one, you see the previous one here, it says values, whereas this one just says value. So straight away that's got me thinking, actually, there's only going to be one answer to this. So I've got to think about where my numbers are. I've got to think about what my answer is going to be. Write down the integer value of this. So first thing I'm going to do is divide everything by 3. So I'm going to get 16 over 3 here. I'm going to get x here. And I'm going to get 20 over 3 here. And here's where it's quite important to be flexible with your fractions. Okay, this could be a non-calculator paper. Now, trying to find the whole number that's between 16 over 3 and 20 over 3, I wouldn't say that's immediately obvious as to what the answer is. But if we turn this into a mixed number, into a mixed fraction, and I say how many 3's go into 16 here, so 3, 6, 9, 12, 15, 5, remainder 1. And how many 3's go into 20? 3, 6, 9, 12, 15, 18, so 6, remainder 2. Well, suddenly that becomes a bit clearer because I'm looking for the whole number, the integer, that's between 5 1/3 and 6 2/3, or the only one is 6. Okay, that's the only whole number that's between those two fractions. So 6 is your answer there. Okay, and that's it because we're just looking for a value. Okay, one value. Now, one last example. This is about as difficult as it might get in terms of the solving combined with the integers. And you just see here, you've got a slightly more complicated equation here. But again, we just solve it as we would do normally. But you must remember to do your operations to every single part of this. So what I mean by that is because I've got 2x plus 1 here, if I had, say, 2x plus 1 equals 12, the first thing you would do is to subtract 1. So I want to do that, but I want to do it to every single part of my inequality. So I'm going to subtract 1 first of all to this. If I take away 1 from here, I just get 2x, and then take away 1 from here as well. So it's important to remember to do it to every part of your inequality, and then divide by 2. And that's my inequality. Now the question says to list all the solutions. It's told me that x is an integer, so I'm looking for integers here, 2, 3, 4, and 5. Check the ends, neither, so that's my answer. Okay, so I would copy that one down as well if you can, just because the equation in the middle there is slightly more difficult. Okay, I'd like you to have a go at the questions in the booklet, and if there's any questions at all, then please let me know. Thank you.